My name is Josh Ulla. I work for Deep Imaging. I'm the Chief Development Officer, as I said. Today I'm going to talk about modeling. I'm going to talk about flaws in models, and then I'm going to talk about the economics of those flaws and how we can fix it. Deep Imaging, what we do is we track fluid in real time. So as you're fracking, as you're settling after you frack, and on flowback, as you have that fluid going back into your reservoir, we can observe all that. So we can watch what is actually happening so you can make profit in total. More excitement I was expecting, but that's okay. We don't need profit, just more data. So I wanted to start. I know not everyone here is a completion engineer. I wanted to talk through what fracking is really quick. The video is working, which is incredible. Marathon Oil put this on YouTube. But fracking is a process where we actually break the rock up in the reservoir, and we get those hydrocarbons out before they wanted to come out on their own. So what we do is we perf the casing. The casing has been cemented in the annulus. And then we flow fluid into those perf holes to break up that rock. It's got some proppant in it, so it holds those cracks open, and then hopefully oil and gas flow back out with some water probably too. And then profit. Now the good news here is that every frac is uniform. They all go at the exact same length. We're looking at map view here, so nothing could possibly go wrong. So now we know all the things we need to know. So if we go to QEP's investor deck from August of this year, they show what everybody's showing, dense development in the Permian. So we have all the way from the Sprayberry down to the Wolf Camp. We know now how far we can splice these wells apart. We know how long the stages should be. We know how big the jobs are. Everything's going to be fine because we had that frac model earlier, and it was very uniform. So thank you for nodding along. Yeah, everything's fine. Surprise, it's not. This is from Concho. They released this, I think, in September of this year. They had done a test called the Dominator test. And they had shown that if they had spaced their wells a little further apart, they would have had more profit, the red arrow showing profit. So what we have here now is that it didn't work. There was some kind of problem, some misassumption in the model that fell flat a little bit. And spoiler alert, someone already gave it away in every other talk that you saw today. But it comes down to creating free cash and actually increasing your production. And it's the parent-child relationship and the well interference while you're doing a dense development. So let's uncover what the problem is and see if we can't solve this together. We got lots of time. We're going to be all just fine. So what did we think was happening? Here we're looking map view down on a well. Is laying down in the reservoir. Every dot is the middle of a stage. The yellow is a very pretty fluid going out. And the crosshairs are the stage that's actually being fracked. Nice and uniform, perfect spacing, everything's fine. That was our model assumption. Now at Deep Imaging, we give the opportunity to actually watch the frack every 1 minute with a 5-minute lag, real time. And we can actually watch as that fluid enters the formation. So let me show you some of the things we've actually seen in the real world. First off, it's never that symmetric. Bi-wing fracks are very rare, and when they do happen, we should celebrate it, not expect it. Normally, we get something where it goes off to one side more, the next stage will be hungry on the other side. That's super common. Most models don't accommodate for that because we just haven't been able to observe this data enough to really get it locked in. What else do we see? Well, I was talking about plugs between stages earlier when I quickly explained fracking in under 10 seconds. If those plugs fail, and the fluid can actually enter that stage from before, think about the economic impact here. Now we're not treating the rock we thought we were going to treat. And in fact, we're wasting all that, the cost of fracking that stage, somewhere between $50,000 and $200,000 to reinflate a balloon we already inflated. This happens all the time. This is a dime a dozen. For cementation, when you cement that casing in the annulus, if it doesn't couple very well, that fluid can run right up the annulus, and suddenly you have communication between all these stages. Super common, once again. And then our best friend from Wall Street Journal and all the media and all the investors and everybody is frac hits. Once again, we see this all the time. We find a weak zone, and that fluid can just run away on us and get into the neighboring well. So what have we found? We found the ghost in the machine, or at least one of them. There's probably a dozen of them, but one of them is that the frac aren't behaving the way we thought we were. So I'm going to end by showing you what real data looks like. So what we offer here is the opportunity through a web browser. You can actually be accessing what the frac is doing in real time if you're in the frac fan, if you're the CEO of the corporation, if you're an investor that was given access, if you're Amazon and you just want to dig into data all day. And so what we're looking at here is map view of what the frac looks like on both those plots. The dots at the middle of the stage. The one on the right is a rose diagram, so it's just engineering, and it's just kind of showing distribution of energy. The plots over on the right-hand side are up and down the well, and side to side going away from the well. And I'm going to quickly show you what 3 stages look like from real data, and then we'll call it quits. So the first one is a nice bi-wing frac. Everything's behaving as we expect. It's got a bias over to the left. There is a parent well half a mile away to the left. but half a mile shouldn't be affecting us. So that seems kind of peculiar. On the next one, we're actually going to see a plug failure here, so the fluid's actually going to enter back into that stage we just treated. And what we can see is we look along the well there with those little dots, we see the fluid entering the orange stage. That's a waste of money. That's production we'll never get. This well's going to be mysterious. And as we reach the end of this stage, the next one we're going to look at is the dark blue stage. The crosshairs are going to move in 3, 2, 1. And this well actually hits a weak zone here. Fluid gets a run on it, and it fracks into the neighboring well. This well actually placed fluid 2,600 feet away. Doesn't help this well, doesn't help the other well. So, dang it. So I want to say a big thank you for Amazon for this opportunity to pitch. We do have 4 minutes for questions, and I think you guys can text them in right now if you'd like, but thank you for your attention. I really appreciate it. Oh, sorry, I was looking at there's nothing going on. Oh, what's our biggest headwind in adoption? Oil price, and then kind of, we saw the plots earlier of kind of how investors are treating the operators right now. The spend is really tightened up right now. And that's probably the biggest thing, is that everyone's tightening their purse strings, and it's kind of turtling up a little bit, which will probably have negative effects in the long term, but in the short term, it is difficult as a service company to be run. All right, well, I've got 3 minutes and 22 seconds. How does it work? What is the science and principle of the imaging? At a high level, it's electromagnetics. So what we're doing is on the surface, not at the well site, not at the well bore, over in the meadow, over top of the horizontal well, we lay out an array of electromagnetics. So we induce a huge electric field, and then we put out voltmeters to measure variations in electric field that are caused by that fluid actually perturbing that field. So it's walk safe 100%. We never change anything on the way you're fracking. We don't ever enter your well site. For MSAs and HSC, it's super easy. It's just electromagnetics out in the field with the deer frolicking. How do you trace the fluid? I think we just answered that, electromagnetics. And what are the limits? One of the limitations is we don't have a height component right now. We only have X and Y, so we can watch these wells interacting side to side. As we progress as a small company, we're eventually going to have a height component. But right now, if you have wells and you want to see how they're interacting, that's what we can do. Okay, that's the same question again. Dang it, okay, I'm going to go to the very bottom one. This is really exciting. So let's say you're fracking a well and you have this data in real time. You're going to sit down and you're watching it happen. Let's say you see bad cementation. This is one of my favorite ones to talk about. You've seen now that stage 7 traveled up the well, past stage 8, stage 9, and then entered the rock at stage 10. Now you've got a decision point. You know that there's full communication back there. You know that if you frack 8, 9, and 10, they're all going to go to the same zone. So option 1 is just go on and put your blinders on and just frack away. Option 2, maybe you pump a cement plug. Actually try to couple that annulus. Option 3, maybe a far field diverter. Option 4, abandon all those stages and go into the next one and save yourself $500,000 to $750,000. But dang it, right now this is happening every day on our wells. The problem is we don't know what's happening. Once you have your eyes open, we look at these type curve variations. We talked all day about modeling. We talked about constraining the model. This helps us lock that model down. Ooh, I don't want to answer the legal liability one. No way. I'm a geophysicist. Did that one. Oh, that was a good one and disappeared. Anyways, I could not read the whole thing. All right, return on investment. Our goal is about a 3 to 4x return on running this. The hope would be that the cost you put out there, you're getting 3 or 4x back in your pocket, either be it on saved operational cost or increased production. What I learned is that a 2-to-1 return, well, for me personally, if I give you $20 and you give me back 40, that sounds great. Oil and gas, not that excited about that. They want at least 60, $80 back. The other one went away. Okay, what is the biggest? We already did that one. Come on, Samir, give me a new one. I'm ready for it. I got 33 seconds. Have you compared it with that? Okay. Oh, it went away again. I'm going to do it anyways. All right. So fiber optics are an option where you can put fiber cable along your well and can watch where flow is coming in and going out. It measures shake and temperature change. We have compared with that. That's a near field study that shows exactly what's happening along your well. We're a far field study that's showing what happens as you enter the rock. Trent Jacobs of the JPT just wrote an article on real time and how we're going to level up as an industry, and he put us tiered there with wellbore fiber optics. And with that, My time is up. We have Ondiflo up next. Thank you very much, everybody.
Ondiflo, we're a startup based out of Houston, and we were born because a lot of children said reconciling field tickets is what I dream of when I'm going to grow up. So that's how Ondiflo was born. And what we were delivering, we had a pilot with BPX Energy here between April and July of this month. And this is kind of what we did with them. We connected the IoT devices out in the field, the truckers that were going and hauling fluids out in the field, and the engineering systems, the SCADA systems, and SAP, the commercial systems, the ERPs on the other side. And during this, we were using a technology called blockchain to enable automation so that nobody would need to touch a ticket manually in order to get people paid. So we connected to 50 facilities. We started with water. These were the IoT, the radar gauges or the infrared gauges were sending tank levels over to their historian database, and they were pushing it out every 5 minutes to us. And based on that, we would be creating and projecting out when will the next haul be needed. A dispatcher would send a trucker. We would track the trucker on their mobile device, identify when they were at the well, when they were at the SWD. We were working with produced water at this time. And based on that, if the measured volume that the trucker reported was within plus or minus 5%, we would then treat that field ticket as automatically approved and send it to the ERP systems on both sides. So other than the dispatcher adding one field of data, who is the trucker, and the trucker adding a few fields of data, this is the gauge level when I started, this is the gauge level when I ended, and the volume that I picked up, the entire process was automated. We did a very, very careful study calculating the cost saved, and the overall savings was about 11 cents a barrel of water with very, very conservative assumptions. That's 11 cents a barrel of water, 55 cents a barrel of oil. So how did we do that? How did we show this proof of value? And this morning there was a conversation about network orchestration. So we had 5 companies using this platform, and we wanted to eliminate a lot of the human touches. So we first identified where were those human touches, what steps were already very manual in our use case, and this was just water hauling, so somebody filling out a paper ticket, somebody else taking 50 of those tickets, going over to the BPX office, having somebody else sign, stamp, code them, bring them back, scan them. Each step was costing money and really not adding value. Somebody who's signing a ticket did not have additional information to be able to evaluate that information that was on that ticket. So we were able to identify how would we actually reduce the risk so that most of these steps are over there because over time these processes were built to reduce risk. So we wouldn't give up any of that risk reduction, but we'd bring in the automation. So it worked, but there were a lot of issues we had to deal with. The most important one is that it's a data science problem. We're using data science, we're using blockchain technology, and we're trying to understand when is a device going silent, where is the data actually not telling me what is really happening. And when we looked at that data, we identified, some problems you can deal with. You can identify based on the anomaly detection that the device is bad. But what about when the device goes silent? And if I want to automate, can I make that automation legally enforceable if I do not have the 2 key points, the 2 data points that actually provide that confidence interval needed for legal enforceability? So these were kind of the studies that we did. We did some sensitivity analysis, and that's how we identified a mechanism to make automation between companies working in the oil field that's legally enforceable. When we started on week 1, we were getting about a 30% accuracy in automating. We ran this for 13 weeks. At the end of week 6, we had crossed 90%. At the end of week 13, we were at 91%. So it gets a lot harder as you go along to bring greater automation into that. But 90% of tickets automated, you can imagine what the economic impact of that is. And so starting from there, with metered wells, with fluids, we can see how now we're in the process of another pilot where we're going with service work and non-metered wells, and we're applying the same principles, the convergence of using blockchain technology, IoT devices, and data science to evidence what is happening out on the field. So that was my last slide, and I believe I've hit that time slot, so hit me, Smear. So right now, the Ondiflo platform runs on one blockchain, so I'm answering that first question. And so everybody who's participating with Ondiflo runs on the Ethereum blockchain in a managed environment hosted by AWS. How are we different from liquid frameworks? We're not talking about electronic ticketing. Electronic ticketing is a required portion of what Ondiflo delivers. We're talking about automating it so that the ticket does not need to be touched. Devices tell us in most of the cases that the ticket is actually real. So that's how I'd say we're different from the field effects type of solutions, which are saying we're electronically capturing the ticket, but then it flows through the same approval process. So the year-end audit, that's a very interesting question. Because we are on a platform and it's a shared platform, the auditor actually has a much easier role. You see, today you have a ticket, somebody stamped it, somebody signed on it. The auditor rarely goes and checks whose signature was that and is that signature valid. By using digital signatures, we can actually enforce compliance on an ongoing basis. So this is one of those big benefits that when you're using automation, your audit is happening as things progress out in the field. And so it's very easy to flag anomalies or deviations. The next question about blockchain technology. Blockchain is only probably 5 to 7% of our code. The biggest part is the data science that makes the evidence of a fact legally enforceable. So when can I say with significant confidence that a particular event did take place? That is, I'm just looking at the next question. Whoever did that, I'm going to be standing right out there outside. Come on over. But yeah, so the audit process is actually made quite a lot more efficient. The integration for SAP, in that last slide that I have, here's something really cool. So BPX just upgraded to S/4HANA, and I don't know much about SAP, but they have something called ERS, Evaluated Receipt Settlement. This is kind of like when you deliver widgets to Walmart, you don't need to send them an invoice. Walmart maintains the inventory, maintains the prices, and they tell you, I'm going to pay you $50 next Wednesday. And unless you have a dispute, you don't even need to talk to them. You will find the funds have flowed into your account. So SAP has provided these APIs that we are consuming, and I'm sure the others, Oracle Financials or Microsoft Dynamics or any of the other ERPs will be there soon. But this is enabling it to be relatively easy, where we can replace those SES sheets and capturing many of the details that are manually done today. So SAP is actually enabling that and making it quite easy. So that's a very important question. So I drove 2,500 miles in the Haynesville Basin in April this year, and I trained 7 drivers in that first week in April. We had 65 drivers use the system. So one of the things that we've done is make it very easy from an adoption perspective. We are going to be up in the Marcellus here in a couple of weeks. And again, we plan to train 5 to 7 drivers. And we're seeing that they train each other because we've tried to make it as intuitive as possible. When it comes to dispatchers, we need to provide a little bit more training. We're trying to provide video and things like that so that they can self-consume and stay updated. How do you hold trucking companies accountable? That's what Ondiflo does. Because one of the key things we've done is we're delivering it on a mobile device, and the trucker is using that mobile device to allow us to track them. So whether they're speeding, whether they're, one of the things, like when the weight man's around, truckers will take less volume. Today, most of the operators don't know when that's happening. But with Ondiflo, now we can show there's a pattern. Oh, yeah, this morning, every truck was 10% less. Oh, the weight man must have been around. So we can hold trucking companies accountable. And we did quite a few experiments. One of them was to switch drivers from hourly to a per job basis. We saw a 40% improvement in efficiency. We did another experiment where we opened up which SWD they could go to, and we saw routing optimization, savings of 160,000 driven miles over 11,000 trips. So definitely we're able to do a lot of that. So I think that's me out of time. Thank you, everybody.
Hello. My name is Tim Buttrill. I'm the VP of Sales at Data Labs. I know it's kind of getting late here, and you may be confusing me with the other tall, red-bearded guy that was up here talking about deep imaging. If so, that's fair. A little thing that you should know about Josh Ulla, though, he's got this Canadian kindness about him that if you come up to him afterwards talking to him about Data Labs, he won't correct you. He'll just pretend he's me the whole time and keep going. So I'll let him do some work for us, too. Data Labs, we build modern web applications to move high-frequency frac data directly from the field into an operator's back office. Why do we do that? We do it to make it easier for completions engineers, reservoir engineers, data science teams to actually get value out of data that you already own. It's as simple as that. But over the past year and a half, I'm so excited about this. We've been wrapping all of this with basically a way for data science teams to deploy machine learning models that they're building internally, that they're building with other vendors, directly to those frontline engineers via our platform that people are using. A little bit about our story. We are up here as a startup, but we are the most used frac data analytics platform in North America. 1 in every 2 completions right now is using Data Labs to collect, manage, analyze frac data. And you know, as a growth person, one of the things that's so exciting to me about this is that because we're AWS native, because we're built on the cloud, scale has always been built in, right? I know that every time we sign a new customer, a new major, they're going to have the same great experience that the customer before them had. And that's so important, and that's thanks to having a system that's designed on AWS to scale like that. Why did we focus on frac data? I really liked Alan's picture of the seismic tapes in the back of the truck. I think I'm going to start using some of those. But you guys have seen this. We've been talking about this all day, right? This data is trapped in spreadsheets and PDF files, and that makes a really valuable data source almost unusable, right? Frac is one of the largest items on an AFE, and it's one of the crappiest data sets. So we should change that. People are starting to do that. We're helping them. But if your data is in Data Labs, it's going to look a little bit differently. Using time wisely, being efficient with data, again, this should be table stakes for this room, right? Like every project that we do in this room should be about reducing man hours for manual data entry and finding ways to clean that data set up automatically. With a mid-size independent, we saw that it was about 2.2 FTEs, but it's going to vary everywhere. This is one of my favorite stories. If you're a Data Labs customer, you've seen this graph before because we love it. The reason that we love it is because we got an email one day from a customer, and he said, "You're never going to believe this. I was sitting at the pool on my iPad, and I just took this screen cap for you and sent it to you because while sitting here, I just saved more than enough to pay for your software this year." Again, sales guy, I love this, right? This is the story that I'm going to tell every chance that I get because this is the value of deploying good data to frontline engineers, right? This is not hard to make a heat map, but it is hard to consistently get the data out in a format that engineers are accepting and using. And when they use it, they find things like this. This is a really simple change, but what he notices, I've got 2 frac companies out there. One is doing one thing, one is doing another. It's actually the same frac design that I've given them. Why is my second service company using so much more friction reducer consistently? And without explaining this entire graph, basically what you see at that changeover in coloring on the bottom is that they recognize that the service company that was using so much more FR just had a little bit of a different water mixture, and by changing that water mixture to a little bit more fresh water, they were able to immediately reduce the amount of FR that they needed to put away the design job. Real money just by looking at data in aggregate on a regular basis. Lastly, I get really excited about this. This is something that our R&D team has been working on for a while, and I think maybe most relevant to the people in this room. But we are doing the work of building the building blocks that I think are going to hugely impact the way that we study completion in the future. So we have all of this raw data coming out of the field, and you've seen great ways to kind of talk about modeling. You've seen some of the work that OAG is doing on kind of the entire picture as a whole. How do we profitably design well spacing? But what we're doing is we're using machine learning to go through and actually identify those small features within raw pump data that help you quickly, automatically categorize that data set and make it something that you can use in the future. I think these models are going to be the building blocks of a lot of the data science that we do around completion. And then lastly, gosh, if there's one thing that I could tell you guys today, especially people who are sitting in kind of operator roles in operations, lean on your vendors to make good APIs and to document them and to provide documentation to everyone that may need to use it. Right? We believe, this is why we're here with AWS and an open ecosystem, that we can get good data out of one tool into another tool using those APIs. We have a number of partners that we've done this with. We're so happy to continue to expand our partners. I'd love to talk to people in the room who would like to partner with us. Anywhere that you want good, clean frac data, Well Data Labs is going to help you get it there. That's what we're here to do. So with that, I'll take some questions. Astros, all right. I'm actually from Denver, but I brought my whole family down here, and we did not know that that was happening. But we're here. We already got our hotel. They can't kick us out now. We have a strong internal-only deployment of machine learning models policy. What kind of data integrations for your real-time streams do you support today? So I think that's a great question. We're building a couple of ways for this. So for those that don't have that rule, we do have a containerized way to deploy your own models inside our application, but we also provide streaming APIs, and we have documentation for that available. So if you have a model and you're already streaming something, you can stream into our user interface via that inbound streaming API. Is your technology only for unconventional wells, or is it also for deep water wells? I think this is really kind of a bit of a question just of the kind of pain of the data analysis itself, right? A part of the reason why we've been successful in unconventionals is because there's 50 to 60 stages, and the same data is being created over and over and over again, and it's hard to manually manipulate that. In deep water, it's not totally the case. So I expect that our technology would be applicable there in the future, but today we are primarily used in the unconventional space. Can you give me an example of an operator actually leveraging Well Data Labs APIs? So yeah, I mean, you guys saw Josh's presentation of deep imaging's fluid just happening, and you saw our nice little logo there. That's the value of co-marketing and good branding. But we're using an inbound API to make that happen, right? So those are APIs that will drive integrations like that. We've got an awesome partnership with WellView, so that field data that's being created by a frac company, part of that manual data reduction, is not having to have a company man type the same thing into WellView that a frac engineer already produced sitting right next to him in the same trailer. How do you handle data from wells that have already been completed? I think this is a great question, and someone else actually, it might have been Alan from Explore as well, talked about kind of the value of what you do collecting data with kind of cloud native application forward, and then you have that question of everything that's behind it, what do we actually do with that, and how do we deal with it? Some of the models that our team is building that I referenced earlier around identifying the start and end of a stage, identifying ISIP and breakdown pressure, identifying a point where diverter hits, all of those things, once you take kind of that raw CSV data that's just hiding in a share file inside your back office, if you put that into Well Data Labs now, we'll be able to actually deploy those models and start to categorize the raw data in a way that makes it much easier to get it into our system and then out into the other places where you need it. Can you do this in real time? You know, I think real-time frac data analytics, if you did like the word cloud of JPT over the past 6 months, that's like the thing that would bubble up over and over and over again. We can do it in real time. We are part of that. We are promoting our ability to do that in real time. I think the other thing that I have a chance to say to you now is be aware of the differences in a data set that's produced in the van and then sent to you after the stage and the data that comes in a real-time stream. We will capture both. We will look at both. We can tell you there are significant differences between the two. and we're going to keep working to make that data set cleaner and better. How are you different from a company like RS Energy or IHS? Hopefully by this point that question is relatively self-evident, but we're dealing with a proprietary data source here that's coming directly out of the field. This is not kind of what my neighbor did data. This is what I actually did data. That said, when two operators are both using Well Data Labs and they have an agreement to share, technologically it is as simple as clicking a button. The difficulty is just getting your companies to agree that you're allowed to do that. All right, that's it for me.